Hello, hi everyone. Welcome to the Student in the Brand. So today we are going to discuss about electric current. Electric current is nothing but the rate of flow of charge. The flow of charge per unit time is called electric current. I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. So we'll see electric current. So now we are going to discuss about electric current. Rate of flow of charge. SI unit of electric current is ampere. SI unit of charge is coulomb. So I equal to Q by T. I equal to Q by T. I am taking I equal to Q by T. So SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So I equal to Q by T. The flow of charge through unit cross section area per second is called electric current. Okay. So I am considering and SI unit. Now you can take SI unit of current is ampere. So small letters you have to write, and here also charge coulomb, and time is second. Okay. Second. Now you can take I equal to Q by T, right? So 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. 1 ampere is defined as 1 coulomb of charge flowing through unit cross section area per second. So I equal to Q by T. 1 ampere equal to 1 coulomb per 1 second. Okay. So I hope it is very clear. Now, so SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. Okay, 1 ampere equal to 1 coulomb per 1 second. See, now Q is the quantization of charge. Q equal to Ne. So why we are taking quantization of charge? Because so here you can observe I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. So 1 ampere equal to 1 coulomb per 1 second. Okay. Q equal to Ne. Q equal to Ne. That is nothing but Q is the quantization of charge. What is the quantization of charge? So here in the conductor, only one electron if it is flows, can we say current is flowing? Only 2 electrons, can we say current is flowing? Only 3 electrons, can we say current is flowing? No. So 1 electron if it is flows, we can't say. So if you are taking positive charge, negative charge, okay. So 2 electrons if it is flows also we can say. Actually plus or minus any, okay. So charges are there inside of the conductor. So if it is flows one, only one, we can 2 also we can say. There are many, okay. Okay. So number of charges are moving inside of the conductor, right? Yes. So number of electrons are moving inside of the conductor. So that's why taking quantization, number of, okay, integral multiple. So like that. That's why Q equal to plus or minus Ne. Or Ne also we can take. Now I equal to Ne by T. Okay. So on one electron, how much charge is present? 1.6 into 10 power, how much? 19 coulomb. So on one electron, how much charge is present? On one electron, 1.6 into 10 power minus 19 coulomb. Okay, now so in 1 coulomb, 1 by 1.6 into 10 power minus 19. Okay, so if it is goes up, 1 coulomb 1 by 1.6 into 10 power 19. So if you do this calculation, 0.625 will get it. 0.625. Okay, so in 1 coulomb we'll get so 0.625 into 10 power 19. Then you'll get 1 coulomb 6.25 into 10 power 18 electrons are present. So this value, so very very important. Okay, so make sure that you are learning this point. Once again, check these points. Electric current. The rate of flow of charge is called electric current. So you can take here. So electric current, I equal to Q by T. SI unit of current is ampere. SI unit of charge is coulomb. SI unit of time is second. 1 ampere equal to 1 coulomb per 1 second. 1 ampere equal to 1 coulomb per 1 second. So Q equal to plus or minus Ne. So inside of the conductor, there are many electrons are flowing. Then only we can say it is quantization of charge, integral multiple. So Q equal, I equal to Ne by T on 1 electron 1.6 into 10 power minus 19 coulomb. So in 1 coulomb 1 by 1.6 into 10 power minus 19, that is 1 coulomb 1.1 by 1.6 into 10 power 19. Then you will get this one. So in 1 coulomb 6.25 into 10 power 18 electrons are present. Okay. So this is about electric current, quantization of charge, and the value 1 coulomb. So on 1 coulomb, in 1 coulomb how many electrons are present? On 1 electron how much charge is present? Right? Yes. Now we will discuss about electric circuit. A continuous and closed path of an electric current is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. So before discussing this one, we will discuss about electrical elements. Okay, so electrical components. So those are cell, positive terminal, negative terminal, positive terminal, negative terminal. Second one is battery. First one is cell. Second one is battery. Positive terminal, negative terminal. Third one is switch, open switch. This is the open switch, and fourth one is closed switch. Closed switch. So cell, battery, so open switch, closed switch, open switch and closed switch. Okay. Next one, fourth one, cell, battery, open switch, closed switch, resistor, 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 and fifth one, rheostat, rheostat. So rheostat. So we can also take like this also. rheostat. Next, ammeter. Seventh one, voltmeter. And wire joining. Ninth one, wire crossing. Okay. So voltmeter, ammeter, voltmeter, that's enough. I hope it is very clear. Check once electric current. So these are the electrical elements. So you can check cell, battery, open switch, close switch, resistor, rheostat. Rheostat we can draw like this, two ways. Ammeter, voltmeter, wire joining, wire crossing. Okay, so these are electrical elements. Now we will draw electrical circuit. Electrical circuit will draw. Electric circuit. A continuous and closed path of an electric circuit is known as an electric circuit. A continuous and closed path of an electric current is known as an electric circuit. So here you can take. So this is the bulb symbol, and here battery, switch. A continuous and closed path of an electric current is known as an electric circuit. Okay, so this is an electric circuit. So current is passing from positive terminal to negative terminal. There is electric current. So there is a conventional current. I can say conventional current. Conventional current. And here we can take, this is electric current, the flow of electrons, electric current. So what is the conventional current? So the flow of positive charges is known as conventional current. Flow of electrons is known as electric current. Okay, so first point is conventional current. Positive charges will move from high potential to low potential. Okay, so whereas electrons will move from low potential to high potential. Okay, so here you can observe electric current. So conventional current. So charges will move from positive terminal to negative terminal is called conventional current. So electric current is nothing but charges are moving from negative terminal to positive terminal. So conventional current will move from high potential to low potential, whereas electrons will move from low potential to high potential. I hope it is very clear, right? Yes. Next. So now we will discuss about electrical potential and potential difference. Electrical potential and potential difference. What is electrical potential? Potential difference. Potential difference is nothing but potential difference. Potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor is called potential difference. So here you can take from point A to point B, we are doing some work to bring unit positive charge. So it's called potential difference. Work done to move positive charge. V equal to W by Q. Work done to bring unit positive charge from one point to another point within the conductor is called electrical potential difference. So electrical potential is nothing but electrical potential. Electrical potential. Electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. So here this is the field. So this is the infinity. So we are doing work to bring unit positive charge from infinity to the required field is called electrical potential. It's called electrical potential. So I hope it is very clear. So potential difference is nothing but work done to bring unit positive charge from one point to another point within the conductor. Within the conductor is called potential difference. So electrical potential is nothing but work done to bring unit positive charge from infinity to the required field. Infinity to the required field is called electrical potential. I hope it is very clear. So this is about potential difference and electrical potential. And next one, so we are going to discuss about so resistors are connected in series, resistors are connected in parallel. So that we will discuss in the next class. So thank you so much for joining and attending. Do like, share and subscribe to Student Debra. Thank you so much.